You know, whether it's like planning an event, like a birthday party, or working on a group project. You know, these are all places where you've used project management before. And as for myself, so I'm a freshman studying EECS and business in the MET program here at Berkeley. My background, I'm a current product manager for web dev. I was a PM last semester for MET Strategic Group, which is a consulting club campus. I've worked on various startups leading teams of 4 to 10 engineers and designers. And in high school, I don't know if this really counts, but I led a 20-person robotics team, all using this practice. So here's some sources. I'll have these slides emailed afterwards to everyone who attended. There's some terms. But first, let's talk like an overview, right? So today's environment of technology development and product development is just a complete whirlwind. There's just a lot of things to keep in mind, whether it's demanding customers, competition, system complexity, requirements volatility, and all this can lead to product overrunning some sort of timeline, runaways, cancellations of projects, attrition of resources, and all these kind of negative things that can happen if when you're building a product. And what this really comes down to is the failure rate in IT is extremely high. Even in 2010, only 33% of projects actually succeeded. And this isn't just startups. This is also internal projects that like larger companies like Google or Facebook are running that were polled. And the most of them are either challenged or fail. And there's definitely a challenge here. It just means that the delivery of the product did not meet the time, the cost, or the scope. And there's a source which you can look at. And requirements defects are the #1 reason for projects failing. People build a lot of unused features. So this means like if you're working on Facebook, for example, and let's say I'm an engineer at Facebook, and I really think it's going to be a great idea to have some sort of like llama button. Where you click a button, a llama prances across your screen. That might seem good for me, but at the end of the day, that's a feature that almost no users are using. And this happens a lot in software. And some other examples of where, you're going to have some requirements, some defects and problems is in design and implementation, but those don't even occur nearly as often as requirements. And another common practice in project management is something called Waterfall. And Waterfall has been used for a long, long time. And it basically consists of planning out all of your project specs in advance and allocating time for them, and then just building all those specs. And this is a process that can take up to like a couple months to an entire year. And you try to plan out everything that needs to happen for the project ahead of time. And this is a system that was very common before Agile and was also extremely bad. It led to a lot of failed projects, which is why Agile was really able to sweep in and make a huge impact on the way that people build things. And what Agile really is a collection of lightweight software development methods that are aimed to reduce the risk of project failure by iterative and incremental development and taking feedback from customers to ensure progress in the right path. It focuses a lot on continuous customer collaboration, value to the customer, and being able to really rapidly respond to change. And at the end of the day, this is all comes down to how can we provide the best value to the customers in the quickest possible way. And here's just some types of the software project life cycle. You start in planning, analysis, design, code, test, deploy. So this is what you call a predictive model. An incremental model, you do this process multiple times in 1 to 3 month sprints. And in an adaptive project lifestyle, you try to reduce this whole process of planning, analyzing, design, code, test, and deploying down to 1 to 4 week sprints. And you really get this really incremental process that allows you to take in customer feedback a lot faster, which we'll talk about. Here's an example of Agile versus Waterfall. In Agile, you have a lot more visibility throughout the entire chain. This is in red. Your adaptability still remains very high even as you go through the project because you focus on iterative small advancements. And the amount of risk that you have very quickly goes down while still being able to provide a lot of business value, because you're taking this multi-step process and chunking it down into really small chunks. So you have shippable code in each of these iterations. Benefits: you reduce the time to market, you reduce the amount of risks, you reduce defects, you can catch them earlier on. You have a higher return on investment in terms of time and money, higher success rate, and the team tends to be a lot more motivated because there's visible improvements as you go. So this graph is really about principles of systems thinking, and it's about your requirements, volatility and complexity. So, you know, if you're in like this crazy stage of like, I don't know what the hell I'm building, that's like anarchy. You have no idea. Versus like you're building like a Facebook clone and you know exactly what that's going to look like. So it's low, as well as technology complexity. So if you're building Facebook, that's relatively low complexity. If you're building something like some sort of decentralized social media platform, you know, there's going to be a lot of complexity there, and that might be higher on the scale. And in general, Agile works at the space of high requirements volatility and high technology complexity. That's where it really shines because of these quick iterative product cycles. So time boxing is an important concept in Agile. It's really like having short fixed durations periods of time in which work is undertaken. And it really alleviates the problems of like work expanding to the time available. Student syndrome, which we also call procrastinating. And because you're reducing these timelines a lot more, so you aren't waiting until the very end to try to do work. We're gonna skip this slide and skip the exercises too. Yeah, so the Agile framework. Agile was born in 2001. And it seemed kind of silly, but there's actually a lot of people who think about these philosophies and these management cycles. And this whole group came together and started building out these systems for Agile software development. And it comes down to what they call a manifesto, which sounds like some sort of political cult, but it's really just a bunch of engineers building things. And what the manifesto is about prioritizing individuals and interactions over processes and tools, having working software over large comprehensive documentation, working with customers versus creating some sort of contract with customers, and being able to respond to change instead of following a plan to the letter. The first principle, so individuals and interactions over processes and tools, is really about the team, right? Agile is about trying to support the team with the environment that they need and trust them to get the job done. And there's a trust that with these self-organizing teams, you're naturally going to come to the best architectures, the requirements, and design. Also, with the team being able to reflect at regular intervals to how to become more effective and adjusting behavior. And this really supports sustainable development where everybody is able to maintain the same pace indefinitely. You're not trying to run short burnout cycles. Working software for comprehensive documentation really means that like you're always going to be able to build and release continuous software to the customer. And this satisfies the customer. And it also really helps the team become more motivated because you're able to see constant progress. Customer collaboration over contract negotiation. This really just means that the business side of things and the product side of things and software developers need to work together daily throughout the project, because at the end of the day, it's about the customer, not about some sort of political maneuvering within the team. And responding to change really just means welcoming changes and requirements at all times. The customer is going to know best, and responding to what the customer wants and hates is the best way to build software. So there's quite a few Agile methodologies out there. Here's a list of them. Scrum is the most popular one by far. And there's some other ones on the side here. And they all fit under the umbrella of Agile. And we'll be covering Scrum mainly because Scrum is the most popular. And Scrum consists of a couple phases, which you can see on this chart. You have a backlog, you have some of these processes like sprint planning, you have your daily Scrum meetings, you have review, retrospectives. We'll talk more about these in detail. But Scrum is really just a structured process framework to develop and sustain complex products. And it's a sum of the different roles within a team, events, what we call artifacts, which are like documents that you produce, and rules that bind a team together. And using these rules, a Scrum team can iteratively build increments of the solution and involve the customer frequently to ensure that they're creating the right product in a proper timeline. It's super lightweight, super simple to understand, but it's very difficult to master and do well. And Tobias Mayer, who's one of the founders of Scrum, he really stresses that there are 5 things that are super important in Scrum: self-organization, collaboration, focus, alignment, and rhythm. And within Scrum, there's a couple roles. These may sound a little culty because they are. Scrum is about creating a very self-organized team that is aligned around the same things. And the development team is, of course, like 3 to 9 people. They should be self-organizing, cross-functional. They create increments of software, and they also set the ground rules. And these ground rules define how these other 2 roles interact with the team. So the team is really owning the process here. The product owner is the voice of the customer. So they define the product vision, and they really think about how to maximize value and keep maintaining a backlog of features and things to build. The Scrum Master is kind of the servant leader, and he's basically in charge of ensuring that this project management process is implemented well, and that the team has the proper working environment and reducing their impediments and interruptions as the team build goes. And in terms of events, events are like meetings and stuff that are part of Scrum. You have a couple here. We'll start from like kind of the largest one, a sprint. So a sprint's like a 1-month time period. This length is very, very varying. In my work, we work in 1 month or in 1 week sprints, which is actually what I prefer. But these really depend on the requirements. And at the end of the sprint, the goal is to have some sort of objective that you set at the very beginning, and also a shippable product. Number 2 is what you call a sprint planning meeting. And this should occur every sprint. They say 8 hours. Normally this takes like 1 hour. But it's really talking about what the goal is for that week, how the backlog includes plans to build it, and then splitting up different stories. And we'll talk about stories in a coming slide between different developers. Number 3 is what you call your daily Scrum. So this is kind of like just a check-in meeting daily, 10 to 15 minutes, just with the dev team self-reporting, making sure that the backlog is being updated, checking if there's any impediments within developers or anyone within the team. A sprint review is just a time to look at the product and really inspect if the product is going well and you're building the right thing for customers. And this is where the product owner can really come into play. And then the last event is what we call a retrospective. And this is looking at the process. So how are we doing in terms of managing the team? Is there any, like major behaviors that we need to change, or things that we could do better within our team to ensure that we're shipping and building better code? And then artifacts are kind of these documents that you can produce and things that you're keeping track of. So the first one and the main one is what we call the product backlog. So this is just a list of features and functions and enhancements and fixes that the team needs to address. And within each item, you're going to have like a description, an estimate of time, a priority. And this priority is going to be determined via like value, cost, risk, and necessity of whatever item that is. And there's only one product backlog, even for like multifunctional teams. Everyone should be pulling from the same background source of truth to build software. Number 2 is what we call the backlog. The sprint backlog. And the sprint backlog is all of the product backlog items for a specific sprint. So whether that's like a 1-week period or a 2-week period. And this can be used to estimate like how much work do we have for each day that we have. How can we schedule our resources in a way that works well. And then an increment is just a number of completed product backlog items in each sprint. So we're going to skip this slide. So then another really common practice is what we call extreme programming, or XP. And XP really focuses on engineering practices and taking them to kind of the next level. So the first one is communication, which is seamless communication within teams and with the customer. Simplicity, design things for today, not for what they might be, and then keep it super simple. Feedback, so that's taking in feedback on the product, feedback on the process, and feedback on people within the team. And the idea here is just to fail as fast as possible. And then courage is to break through barriers, so really focusing on feedback and being innovative and pushing new ideas, even if they are kind of risky. And of course, the last one is respecting everyone within the team and respecting the customer. Yeah. So within XP, there's a couple roles that are involved. The product manager is the product owner, and they kind of maintain the vision. There's a coach, and they focus on the process, making sure that XP is doing well. Domain experts kind of set the rules for each domain. So you might have like a back-end expert, front-end expert. Your sponsor is going to be whoever's the upper manager in the project. So, if you're in like a large corporate company, it might be kind of a general manager that's focusing on like funding you. The customer, of course, and the customer they kind of define the product and prioritize the product. And, there's a big focus on listening to them. You have a designer, both interaction and graphic. So you're really breaking it up into, both like how is the user interacting with the product, and then how does the product actually look? And these are two very separate things that XP prioritizes. And then the project manager, focusing on like interacting from like a team of programmers to the rest of the company. And then the programmers, of course, are just like specialists. They may be architects, they may be testers, network architectures, all these kind of roles that are within the team. And there's a couple practices that XP revolves upon. I won't cover all these in depth. But the whole team, the point is to be very cross-functional, self-organizing, and all-encompassing, right? Your team should cover everything that you need to build a product. And then going inwards, collective ownership, coding standards, sustainable pace, and continuous integration. These are all practices that help the engineering team. And then going all the way down to like the smallest unit, which is going to be like pair programming, in which you pair senior devs and junior devs to work together to ensure that good code is being written. Simple design in both code and product. Refactoring code quickly to make sure that you only have good stuff inside your code base. And then focusing on test-driven development, so you always have high-quality code the whole time. The next one we'll be covering is lean. So lean software development is about minimizing waste, right? So while Agile is, really trying to maximize software's value to the customer, lean really focuses on optimizing the whole process with speed and sustainability. So the 7 main principles. The first one is eliminating waste. Second one is empowering the team. Number 3 is delivering fast to maximize return on investment and get quick feedback. Number 4 is optimizing the whole product. Number 5 is build quality in. So this involves testing, some sort of CI or integration tests, and constantly refactoring code to ensure that quality is always built in. Deferring decisions down the line. So never making decisions without the proper amount of data. You can always put them back later to mitigate uncertainty, which allows you to reduce waste. And then trying to amplify learnings with short product iterations. And there's a couple main forms of waste in software that lean defines. The first one is partially done work. So this is like specs that are waiting for dev or code waiting for QA. This is stuff where you just need someone to step into the process and take care of it. Number 2 is extra processes. So this is like bureaucracy, documentation, approvals, stuff that you don't need and that just slows people down. Extra features. This is stuff that doesn't add real value to the end user. Stuff that the engineering team might want to build because it looks really cool or it might be fun to build, but isn't really needed. Number 4 is task switching. So focusing that engineers and people are focused on what they're building. Number 5 is waiting and delay. So whether you're waiting for reviews, for approvals, waiting for feedback, just slow communication in general can kill a team because it reduces those product cycles and kind of lengthens the amount of work. Motion. So how can you quickly hand off information and projects from one team to another? So whether this is within your team or within a couple teams, optimizing that process. And then defects, which just might be, broken code, documents that are wrong, requirements that are incorrect, and these are all forms of waste. Next, the next form of project management that we'll be covering is Kanban. So Kanban is an agile methodology that focuses on continuous delivery without team burnout. So it's really about focusing on the cycle time. So how quickly can you take a feature and release it for the best throughput? And there's 5 core principles. The first one is to visualize the workflow. So you guys have probably heard of tools like Trello or like Monday.com or Jira, or a lot of these tools that allow you to really like organize and track your whole workflow. Limit WIP, so this is like works in progress. So this is to really try to focus on small things at a time to avoid overcommitting, minimizing waste and initial cost. Number 3 is managing flow. So how quickly can you move stuff along the chain? Number 4, make process policies explicit. So this is to make everything feel natural, right? An engineer should be able to step into a Kanban environment and know exactly how to work in it without really having to like ask managers. And then the last one is being able to improve collaboratively. So this is like trying to look at team behavior, whether it's from like a scientific perspective or trying to model it in some way, and trying to improve behavior in small steps. Here's like an example of like a board in like a Google Sheet. So you can see you have like a backlog. You might have some items that are selected for development, some stuff that's being developed, ongoing and finished, acceptance, that's like a review system, and then deployment. And you can see here, actually each column is limited, right? You can only have so many items in here. And this is to reduce the amount of works in progress that you have so that you have predictable throughput and that like, how much your team can constantly maintain. So doing Agile. Agile has what are called ceremonies, and ceremonies are kind of these like different terms and behaviors that are very common within Agile teams. So the first one and the most important one is user stories. So these are kind of short, simple descriptions of what a user wants in their language. And these are typically written by customers. And an acceptance criteria, or like when this is done, that is also part of this as well. So these are small enough to fit inside of a iteration, so like a sprint, for example. And if it's too big, then you can split it up into multiple stories. An example might be like, as a user, I want to do some sort of feature so that I can have this benefit. And having this format is really important because first, it defines who this is providing value to, provides what exactly you're providing to the user, what you need to build, and then you're providing the benefit that it has to the user, right? Agile is all about how can you provide more value, and a very explicitly putting this reason and this benefit in is important. So an example might be like, as a frequent traveler, I want to reserve a hotel room, right? That's a very basic story for like some sort of hotel booking software. Another format is like given, when, and then. This is used for like larger system-based requirements that aren't focused on the user. This might be like, given the user account is valid and when the user password age is more than 3 months, then force them to change the password. And these are more from like an engineering perspective and less so from a user perspective. A couple of different types of user stories. There's business or functional ones, non-functional, bugs, spikes, documentations, technical. But at the end of the day, these are all like just small, very valuable chunks of work that can be negotiated or talked about within a business to find the right amount of cost versus performance. And these should be something that you can readily estimate and test. So for each story, you should be able to say, okay, our team can probably do this in like 6 hours total. And this should be testable at the end of the process. And that's really important to ensure that the stories that you're building are the right stories to build. There's 3 C's that you generally follow. This is like a XP thing, but it kind of works for in all sorts of projects. The first one is card. So you want to write like a short statement of intent. An example might be like, as a user, I can log in and gain access to the internet so that I can collaborate within the org. That's, the next is like a conversation. So there should be some way for you to discuss with your team, some side effects or things that might be important within that story. And then it's a confirmation. So this is like what exactly you're going to be considered done as. How do you know that the feature that you're building is going to be complete? You can actually put these on index cards. This is like back in 2002 when this was developed. There wasn't really software for this, but now this is something that's like integrated into most software, right? You have some sort of story number or ID, an estimate of the number of hours, description of the story, a priority. So how important is this to the team? And then how do you know that it's done? And this is like a great visual way to see all the different parts of the story. And, Agile, when you're building out requirements in Agile, you can break it down into a couple of things. You have what are called epics. So these are like massive user stories. An example like for clicked might be like a user can go through an experience, right? For a product like Facebook, it might be like a user can, see a feed with all of their friends' posts on it. And these are like just massive stories that are going to be able to be broken down into like smaller stories. A theme is a collection of related ones. So this might be like user accounts or user posts. And these are kind of smaller chunks of a larger story. A task is what we just talked about. So that's going to be like a single user story with like some sort of point value on it, some sort of requirements. And then, so trawling techniques is how you get these stories and how you build the right stuff. And this might be done in like interviews, focus groups. You might do some prototyping or wireframing to test with users. And then a big concept here is also disaggregation as well. So trying to split these large stories down into the smallest chunk that you can. And small is very important here because that's what allows Agile teams to build stuff in small iterative manners. I'm going to skip through this. So sizing is something that is part of Agile. So you can do what's called relative estimation. There's no real units, and it doesn't even necessarily correlate to actual time effort. It's just really about being able to compare relative to something, how much work or effort or time that it's going to take. And this is going to be all inclusive of like testing, of effort, of risk. How should we rank this in the terms of like, should our team be taking this on the sprint? Is this something we can handle? And this is normally done like a Fibonacci scale. Now a lot of teams tend to estimate directly in hours. So that, there's a couple ways to do estimation and sizing. So this is like your ideal time. How long does it take to complete a story if you were just like to work on it uninterrupted and not have any time waiting for like reviews or any of that stuff. And all these different tasks and stories come down to try to build minimum marketable features. And this is kind of like a package of functionality that's complete enough to be useful, but small enough so that it's not the entire project, right? And you can see like a phone, for example, can be broken down into a bunch of these like marketable features. And each of these builds upon the previous one. And each of these is like independently shippable, but isn't comprehensive for a project. And this is what allows you to have these short product cycles to develop software in sprints. All right, skip that. So project vision, how do you actually define a project, right? This is going to be focusing on both high-level product efforts and really looking at your target customers to make sure that you're building features that work for them. And normally this is defined in some sort of project vision meeting. And you set your goals, your assumptions, and your risks of the project to make sure that you're building the right thing. And you compile it down to an elevator statement. And it's going to be like a 2-minute statement on why this is a good project to build. It does not discuss who or what or when or where, just why. People will also put this inside like a tweet. So really just try to compile it down in 140 characters to make sure that the vision is clear and very well defined. So in terms of planning, like this is what an Agile plan might look like. You have your product, which you can break down in like a roadmap. And this roadmap might be like, at the end of Q2 of 2021, I want to complete, like a rebuild of the home screen on my iPhone. So that's like a larger roadmap item. Each roadmap is broken down into releases. So these might be like bi-weekly or monthly. And then those are broken down into iterations. So an iteration, which we talked about, might be like a week iteration, like a week-long sprint or a 2-week sprint. And then within that iteration is going to be a bunch of stories. And these stories can be broken down into like tasks, even smaller. So you can see now how like Agile really allows you to take a product and try to chunk it down into these really, really small tasks really quickly. And the product roadmap is, it's just a visual overview of the releases and its upcoming features. Here's an example of like one that might be for like your generic software platform, right? And you can see it's breaking things down into like half-yearly cycles. Release planning. Releases are when you actually deliver the new functionality that you've built to the end users. And these can either be driven by some sort of scope or by time. So you might want to release, as I said, every like month, or you might want to release like once you finished these features. And these are very iterative, and they can span 3 to 12 months. We don't cover release plan. So the sprint backlog, here's an example of what that might look like. You can see you have like a user story. So your user story is going to be some sort of like larger feature. And then within that feature, you can break these down into smaller tasks, right? So, if you're having a story to like implement like the medium text editor, this might first, you might have to code the interface, and you have to code the middle tier, which is like your communication between front end and back end. Write the online help, which is like documentation, add error logging, and then test it. And the idea is that you try to break down how much time these are going to take in points. So you can see that, as the day goes on, you can see how these points are being completed throughout the project. And the daily plan or the daily stand-up, this is really about like, what features are we going to be building today and working on today? And this is the time for anybody in the team to drop any user story that they want to, even if it's not feasible in the current sprint, if it's important to the customer, right? Because the end goal is always the customer, and any of these processes can be interrupted if there's something that the customer wants that you need to build. On the sprint review, which you talked about, it's time boxed to 4 hours. So you only chunk off 4 hours for it. And it's really a time for you to inspect and adapt the product. So, look at after a single iteration, like a sprint, a sprint review, you can groom the product backlog. So that means like taking stuff out that isn't really providing a lot of value or putting stuff in that you think will provide value. And then updating the product backlog and then starting the next sprint. And this is a very like continuous cycle to constantly improve your product and improve what you're building. And then the retrospectives, as we talked about, are focused more on the team. So these are also time boxed. And the power of time boxing, as we mentioned before, is that you're really able to press a team into focusing their efforts into a small chunk and ensure that you're not wasting time. And retrospectives are about processing feedback on improving team productivity and also code quality as well. And there's a couple different types of retrospectives. The most common one is going to be your iteration retrospective, which is going to be like after sprint. But you can also have them after releases or once a project is completed, as well as just at any point you want to. And there's a couple games you can use for retrospectives. I won't go into these. I'm just going to look at the slides. And the next thing we're going to be talking about here is artifacts. So artifacts are like stuff that you're producing during an agile process. The first one is going to be your business case. And this really covering the project from like a business perspective and from a user perspective, while analyzing the risk like financially, and as well as like the missed opportunity cost, right? And you might do something like SWOT analysis, which is like strengths, weakness, opportunities, and threats. But this is from like a very higher level. What kind of value does this project provide to the business? The project charter. So part of Agile is this weird vocabulary, and a charter is just like formal authorization to start the project. This is going to have really less concrete requirements. So it just might be like, hey, the business team, we want to provide additional value to our customers. So we're going to have you guys build out a story feature for our social media application. So that charter just acts as like an authorization and defines who's going to be working on it, why is it being worked on, what exactly is being worked on, as well as setting kind of your time and cost targets, as well as what success looks like. And it's going to also set out your constraints, your risks, who's participating and what their roles are, and the vision of the project. And then from there, you'll start building out your product backlog. And this product backlog is going to be both business and technical, going to contain bugs and documentations. And the backlog is really going to be built out based on what the charter says to. Let's skip this slide. And then the requirements aren't really necessarily produced all at once, right? In like a waterfall process, you develop all your requirements the moment you get like authorization to work on the project. And you might just go through and like try to do customer interviews and just try to define every single thing you need to build all ahead of time. Agile says that's bullshit. Agile says that requirements should be established as you build the product, right? So focusing on releasing and shipping software as fast as possible so you can get customer feedback and shape your requirements, like as you build the product. And this really allows the customer to get a better return on investment, and it allows the team to build a better product. We're going to skip this. So engineering practices in Agile. So there's a couple engineering practices that are really important when leading Agile teams. The first one is continuous integration. So this is a process that automatically integrates software changes, verifies the quality of these changes by running tests, and reports errors immediately. And what this does is it reduces defect cycle time. So it allows you to catch bugs and errors earlier in the process. And continuous integration might be done via a computer. So you can set up a series of automated tests to do it, or just try building the code and make sure it builds before working on the next thing. or it might be manually done as well too, right? You might have like some sort of designer or product owner go through your changes and make sure that like the UI looks good. And this integration process, yeah, here's just a diagram. It just covers tons of things, but it often starts with the version control system and building your code. And then you might have some code analyses where it just looks at the code. It might run some unit tests, check your coverage, actually build it. Deploy some sort of test environment, run some automated tests on that whole environment. So these might be what you call like end-to-end tests, where you actually like have the computer click on buttons and make sure it makes sense. Then you publish reports, which is like, hey, these tests succeeded, this stuff failed. Send that off to the dev team, and then they start again writing more source code. And this verification and validation addresses human mistakes, but not just those. It also addresses like communication challenges. So within like a larger system, like is your code working with the rest of the system? Making sure that there's no problems there. And it lowers the defect cycle time and the cost of changing software. Another process that's really popular is what's called test-driven development. It's also called red, green, and clean, or red, green, and refactor. And this is writing your tests before you even start writing code. And these tests are going to be automated and unbiased. And it can be broken down into 3 steps. The first one is writing a test that fails. This is called red because you're going to have errors. Number 2 is writing the code to make the test work. That's green, how your tests are fixed. And then taking a look back at your code and making sure to refactor it and make sure it's clean, which is the clean portion of it. And this process allows the team to quickly ship code that will work. And this clean process ensures code quality throughout the whole thing. So acceptance and test-driven development. The tests, of course, are important to build. And the tests are all built around the story, right? How can you look at the stories that you have and the acceptance criteria together to fulfill some sort of business requirement. And you then distill these down into some unit tests. You can ignore these for now. And then develop it with that red, green refactor method, and then provide a demo to whoever the stakeholders are in that specific feature. And that's kind of the process of acceptance that ensures that, like, beyond just making sure that it passed unit tests, that whoever is in charge of the project is liking the feature as well. So Agile practices, value, right? Agile is about value, and business value is about perceived benefit minus perceived costs. It's how can you provide value while reducing the amount of time or energy or manpower that it takes to create that value. And value is what the customer is looking at and ready to pay for. So ways, and another way to maximize value is to minimize risk and wastages, which is why, like lean, for example, right? We talk about lean focuses on really minimizing risk. And the idea is just to fail fast to reduce the amount of risk, right? If you can chunk up your risk into very small chunks, you can take it like by week, then that when you embark on a project, you're going to be able to address, those week-long cycles really quickly. And then, of course, frequent customer product feedback to ensure that product is being shaped correctly. And then Agile, as I said, is very value-driven. So there's a practice called value-based analysis, and it's looking at work items and just considering the business value of them. So it's, going through the backlog and looking at like how much is this feature actually going to be used versus how much development time or risk or complexity will this feature introduce to the engineering team? Let's skip that. Yeah, here's some more games. There's games like Prune the product tree. So this is kind of some funny stuff that people do. Okay, so spikes. So a risk-based spike. Spikes are like technical investigation to research answers. And these help you estimate the amount of time like some sort of task will take. And it's really a way to like create a very short proof of concept to remove uncertainty from like how much engineering capacity will it take to build it. And if you can't find a solution to some sort of critical blocking problem within spike, then you'll reach a condition called fast failure. For example, if there's like some sort of technical issue that you just know that you won't be able to resolve, then you can fail fast. You fail super quickly before even embarking on the actual feature. And spike helps you learn about risky features or technologies to better, estimate or develop new ones. Velocity is a very important concept in Agile, and it's the amount of story points or ideal hours completed per sprint. So this is like a way to sum up like how many tasks can you realistically complete within a time period. This does not include like bugs or rejected stories, and it's not really a measure of productivity either. It's proportionate to team composition. Some teams will have like a very high velocity. You might be able to complete just tons of points each week. Some teams might be going slower, and this isn't like a comparison game. You can't even really compare your velocity across projects, but it's really about being able to constantly improve your own team, right? You can determine like how well your team is improving in terms of task completion, and it can really help you determine how much work can be completed per sprint, so that you can properly estimate the amount of time it takes to ship a product. So here's a graph of like a velocity graph with like your average and then your rolling average over 10 sprints of your velocity. We're going to skip this exercise. So tools and techniques. Progress elaboration is like a technique to reduce iteration cycles and ship faster. So this is what we call like rolling wave planning. It's just basically a way to like take tasks and requirements and constantly plop them inside your backlog rather than like waiting for big chunks. Burn charts and graphs. These are all ways to visually look at performance. Burn down charts are like work remaining versus time. So this might be like how many points do you have versus how much time do you have left. How many points do you have to complete per day if you were to get all the tasks done in that sprint. Burn up is the opposite. And you often put these both into one chart. And these can be applied at like a sprint level, at a release level, or even at like a product level. And it's like a great way to just visually see the team's capacity. So here's like some examples of graphs. These are really great when you're working with like an engineering team, because you can very clearly see like, is it realistic that we're going to be able to complete this project on time based on how many points we have and how many points that we've been completing over the last couple of weeks. Kanbans and task boards are also very important tools. There's a couple different types, but here's one with like Post-it notes. And once again, Kanban is about optimizing work throughput and not necessarily resource optimization. And there's like software ways to do this. Normally, you also limit the amount of items that you can have inside of these columns. So you might say like, okay, we're only going to have 2 to-do items in here and only 3 items in development. And this is just to ensure that your throughput is going to be proper and you aren't like overburdening your team in any step of the process. We're going to skip the information radiator. Feedback techniques. Yeah, so this is talking to the customer, right? And it's ways of like confirming that the value and the features that you're building are going to be good for the customer. And it's hard to really determine that, because a lot of customers will say like, I know good value when I see it, but they really don't provide a way for you to know what kind of value that is. So this is really a process like just very quickly test features, get feedback, and then evolve your requirements based on that. And this can be done with like prototypes or simulations or demos, or even like different types of testing, like A/B testing. Prototypes are very important too. You can have like proof of concept, which just tests like, hey, this is going to work. A visual prototype, this might be like UI mockups. Functional working prototype is like a MVP. And then a form study is going to be like a visual prototype that like looks good and is fake usable. Wireframings, there's low fidelity and high fidelity wireframes. Normally you start with low fidelity and you work with users to ensure that like, the interface makes sense. And then you go to high fidelity and you test that with users to see like, hey, does this UI, does it seem like a usable product to you or something that you'd be interested in? Here's like an example of a wireframe. Personas are a way to like create fictitious people that might interact with your product in order to determine is this end user going to want this? They're not a good replacement for requirements, but they're a great way to like fake people and look at things from a customer perspective. Here's an example of like someone that we're going to call like Angel. She's a social media marketing director. You can even create demographics or goals and challenges. And these are just ways to like determine like, hey, this is the kind of value that we're providing for these kinds of users. I'm going to skip story map. So Agile Tooling, there's a couple different tools to use it. Sophisticated tools can make barriers and reduce the volatility because it just disguises it under like nice UI. And Agile tends to just use really low tech but high touch tools, right? Tools that you need to interact with a lot, but don't provide that much technology or don't require that much technology. Here's a couple. This is kind of an old deck, so a lot of this has changed recently. But like some of these tools are great ways to provide a framework and structure for an Agile team. So being Agile, communication is really important within the team and within stakeholders. And this is to reduce what's called the gulf of evaluation. And this is like a misunderstanding between team members or between management. And you can do this with like having like what are called war rooms. This is just really getting the entire team into a single space, what you call like the information space. And I think war rooms are really critical for building things collaboratively. I want to skip this one. Stakeholder management, we'll also skip this one. Soft skills, yeah. So the soft stuff is hard. All the hard stuff that I've been talking about is pretty easy. But when it comes down to like emotional intelligence and like negotiating, active listening, conflict resolution, these are all super and critical things for working in teams, but often hard. We'll skip through some of these. What high-performing teams look like. So high-performing teams look like high motivation. And there's a couple different ways that you can look at motivation. Maslow's hierarchy of needs is one of them. This is like looking like, hey, like your basic human needs, and then going all the way up the chain, making sure that all those are fulfilled. Having like clear roles and responsibilities, providing structure, looking at the big picture, right? Providing some sort of product vision, and then aligning each team member's aspiration to that project goal, and then recognizing them for any advances they make. These are all great ways to make sure that your team is motivated. Here's Maslow's hierarchy. There's also like Herzberg motivation hygiene theory. So the presence of like these factors like company policy, supervision, these will not make one satisfied, but without them, they're going to be unsatisfied, right? But these up here, like hard work, responsibility, recognition, achievement, and growth, these will motivate people, but they won't get them to work, right? You need these baseline stuff before you can even get here. Yeah, and high performance teams are teams that are super focused on their goals and are able to consistently achieve high business results. And the leaders manage the principles and the principles manage the team. And these principles should be very clearly defined within your team, such as like management principles, environment, having the right people, having like a very small team that is committed to the same thing with common goals, and working at a high velocity and sustainable pace. This creates kind of your all-star team that everyone dreams of. And building empowering teams, it's really about like empowering individual people and empowering developers to take responsibility and ownership for themselves. And qualities of empowered teams is being able to self-organize. The team itself should be able to manage themselves without some sort of external pressure. And there's enough motivation and commitment within them to do that. And this can be done with like servant leadership within a manager. And another thing is like self-directing. Teams should be able to create their own norms and make their own decisions and improve themselves without someone telling them what to do. Team space, this isn't really applicable now because of COVID. Coaching and mentoring can help too. It really helps the team develop closer relationships within themselves, but also provides responsibility to both sides of the equation, which just makes them more committed for their work. Teams should participate within the decision-making process. Everyone should feel like they have an active role in creating the product and in making product decisions. And of course, it's never going to be like fully unanimous. It's never going to be 100%. Majority is never good. Plurality, like the largest block of people, which means like there's some like 30%, 20%, 15%. And then of course, dictatorship is the wrong model. You never want to be a dictator because this will destroy team motivation. And then, management and leadership aren't the same thing. Even though this is project management, each PM has a responsibility to also be a leader, right? Management is about getting people to do what needs to get done. So this is like, efficiency and speed and practices. And then leadership is about getting people to want to do what needs to get done. And that's some of the things that we just talked about, like empowerment and effectiveness. And what this really comes down to, what all of Agile comes down to, is servant leadership, right? You should be a leader who is shielding the team from interruptions by taking care of it yourself, removing impediments to progress. So even if like practices like daily stand-up meetings are hurting the team, it's your responsibility to remove those practices. Constantly recommunicating project vision, right? There should be something you drill into their head. And then, providing the support and the tools and encouragement, rewards, and recognition so the team succeeds properly. Yeah, so continuous improvement is important for Agile, and it's in that plan, develop, evaluate, and learn for each project iteration. And this allows you to like enhance the project constantly and the product. And there's some different processes and tools that you can look at. I'll let you guys read these slides later if you want to. And yeah, some more stuff. Let's skip through this. Agile adaptation. So as like students, especially within WDB, it's not realistic to like try to implement every single part of Scrum or every single part of Agile within the team, right? I'm of the school of thought that like each project is unique, each team is unique. Practices should adapt to the team. And this is why like retrospectives and reviews are great platforms for driving process changes, because it allows you to look at what you're doing from a higher level perspective and be like, is this actually providing additional value? So it's like, yeah, this is what you call like process analysis. Some anti-patterns of like Agile methodology is like having a one-size-fits-all attitude. It never does. Being intolerant about changes, having like sort of heavy bureaucratic system, only using things once and not really testing things in different types of weather, embellishing roles or ceremonies, and trying things without actually testing them first. And some great success signs that your processes are working well. Your leadership team is still working, deliverables got shipped, and the team is going to work the exact same way the next time. And this kind of like a step-by-step process to like apply new practices when you're changing things. Yeah, so putting all together, this is kind of the last couple slides. Agile really helps with requirements volatility when you're working with new technology and to deliver high value while failing fast. It provides value to every single component of the team, whether that's the customer, the end user, the sponsors, or the org. And it's pretty easy to get started with Agile. There's a bunch of different like people and organizations and groups and software that are really trying to implement Agile. But Agile is hard, right? There's a lot of anti-practices. Like if your Scrum is lasting 45 minutes, that's bad. Your meetings should never last that long unless they're like reviews, right? And a great way to kind of start this is with like a pilot project. This doesn't really apply for us. And then also being like this practice called Shuhari. And it's looking at like, how can you implement new practices? So like the first one's like a student, right? Getting accustomed to Agile just straight up from the documentation. The second one is really understanding why. Why do we need Agile? Why is it created this way? And then from there, being able to like actually own the practice and create new approaches, but also always being able to fall back to being a student, right? Every time I lead a new team, I keep learning from each team how to lead better and how to manage better. And yeah, it's kind of it for me. I was a long spiel, so if you guys have any questions, please feel free to spit them out. Cool. Sometimes that's good too. I'm going to send out a feedback form in the chat. So if you guys have any feedback on this presentation, feel free to plop it in there. I would love to hear it. And I'll wait around for another like till 8:45 if anyone has anything. Or just chat about whatever. There's like 12 people here now, so it's chill. Thank you, William.